Welcome back to the final video on how I use Photoshop to produce patterns. Well, we are on the 8th video, and finally we have reached the point of actually producing a pattern. So we use this word pattern, but what actually is one? Basically, a pattern is information presented to us at a visual level. Everything about it is information. At this stage of having first drawn a block using measurement data that produces shapes representing regions of a body, the shapes themselves are information. Not only do they inform us as to a person's dimensions, their unique measurements, they also inform us about the level of fit the garment made from the shapes create. That in my case, they result in a smaller garment along the horizontal axis that would require the garment to be made from a stretch material in order for it to accommodate the person's true body size, as well as the sophistication of the shapes to take on three-dimensional properties that will allow the garment to adhere better to the contours of the individual's form. Other information to be seen at this stage are the labels indicating what area of a region of the body the various shapes are associated to. And as I have been speaking and drawing in a bust line, this is information that indicates the position on the body where the shapes align. So we already have considerable information regarding the individual for who the garment has been designed for, what kind of characteristics the material for the garment should have, that it should be stretch and expand, and what kind of fit, and so appearance the garment should take on wearing. But what else can we include? What further information do we require? Well, we use a pattern to help us in the construction of a garment. So we need a means of representing how we intend to join the various shapes together to form the overall garment. In other words, seam allowances. The word seam in its origins means to bind. To sew means the same thing. In our contemporary understanding, sewing is the act of binding, uniting two or more edges together, the result of which is a seam, a line, a scar across the united surface area. In our conventional understanding, the act of sewing is the binding of two edges of typically fabric with a strand of fibre. And while we can sew rubber sheeting together in this manner, the modern-day prevalence of the myth that we cannot do this has led to the belief that we can only glue edges together. But whether we sew or glue the edges of our pattern shapes together, we need a means to do so. To simply attempt to glue the butted-up edges of rubber sections together does not result in a sufficiently strong enough uniting. As such, we need a seam allowance and an additional amount of area to the edges of our shapes. With sewn garments, this additional allowance to edges is typically needed to produce a sufficient margin of fabric, which limits the possibility of the fabric fraying over time to such an extent that the seam, the sewn line, threatens to come undone. With glued garments, this additional allowance to edges is typically needed to produce a sufficient margin of rubber that permits for the overlapping of edges, that is to say, an extension to the shapes, resulting in more surface area at the edges for glue to be applied. Just as sewing can have multiple different types of seam allowances, depending on how edges are to be sewn, so too can glued edges have different types of seam allowances. But I am only going to go for a traditional basic step seam, the type most commonly used in latex garment construction, in which neighbouring edges that are to be joined will have an equal amount of seam allowance added to them. In my case, these seam allowances will see the edges of neighbouring sections be extended by 4 mm, that during construction will result in an 8 mm seam overlap. So, as I have been talking, I have made copies of the 4 shapes of the garment, and using the ruler tool for measuring the 4 mm distances from the edges, I have then used the direct selection tool to isolate the various points, the corners of the shapes, and then drag these out to their new locations. When we extend these edges outwards from their original shapes, one thing we pay attention to is how they appear at each end. That is, how they appear to run into adjacent edges. In my case, this is largely how they run into the top and bottom edges. What we want at these points is to see the continuation of the orientation of the edges. So as well as being extended outwards, we also often have to extend our corner points in perpendicular directions, and on occasion change the angles of the corners. With curved edges, we sometimes also have to extend or reduce the manipulation guides that form the curve in order to increase or decrease the amount of curvature to maintain the overall seam allowance. Most of the additional information we include in the conversion of our block-worked shapes into a pattern tends to occur at their edges. Such information reveals the seam allowances we have added, which in turn inform us as to the amount of overlap needed when constructing a seam. But other adaptations to an edge can also include the manner in which the garment can be opened up and closed up to permit access into it for wearing, and this can vary depending on the type of closure method we intend to incorporate, such as eyelet lacing, zippers, clips, hooks and eyes, buttons, etc. For my garment, I intend to use snap fasteners down the centre back edge. First, I draw some circles using the circular shape tool. These are drawn to the exact same size as the snap fasteners I intend to use, in my case 1¼ centimeters in diameter. These circles are then positioned into their locations along the original back edge of the back shape. I next produce shapes that can either surround the individual circles or, as in the case here, surround the whole series of circles. This rectangular shape represents the section of rubberized fabric I need to include in my garment that will stabilize the rubber, that is, prevent it from stretching, that will then allow the snap fasteners to do their job without concern that the act of opening and closing the snaps will undermine the integrity of the latex. This stabilized area is around 1/4 centimeter larger on all sides of the snaps, but around 1/4 centimeter smaller than the surrounding edges of the garment shape. As such, the seam allowance I added to the centre back now needs adjusting by being extended further out. In my patterns, I often like to play around with the internal area of the stabilizing piece to give it some kind of textural quality to distinguish it, but something like that is purely personal. I also tend to replace the circles for X-type crosses. This allows me to see the exact center locations for the snaps, the points where I need to make a hole in the rubber for the snap fastener pins to push through. The length of the lines forming the crosses are the same diameter width of the circles, so 1¼ centimeters for me. At other edges, we see that no change occurs. They have no seam allowance added. They have no method of closure included. This is because either these are open edges, that is, edges that do not join to others, or will become fold lines, that is, edges upon which we are meant to flip the shape over to produce a mirror version of itself when marking around the shapes on the rubber sheeting. One thing about open edges is that the rubber in these areas can stretch more easily than more internal areas. So one thing that we can do is to laminate strips of rubber around them. This thickens the rubber and so adds extra resistance to stretching. While we do not have to include this on our pattern, I often do as a reminder that the option exists. Around the open top edges, I therefore bring in the edges by 1/2 centimeter because I would normally include a 1/2 centimeter wide trim around them, but a 1 centimeter wide trim around the bottom open edges to give the rubber a bit more resistance to stretching here, and so tighten the fit underneath the breasts. I typically make these trimmed edges appear as dashed lines to distinguish them from the seam allowances. And that is it for this pattern. I have no further lines to draw, no locations to mark for where pockets or applique may be placed, so any further information I include is via words. Here I include the number of pieces of rubber I need to cut from each shape, well, each template now. One for the right-hand side of the body and another by flipping the template over for the left-hand side. And I most definitely include the orientation of any shapes in which I might possibly get confused as to where its top and bottom, etc. might be, but I'm not worried about that for these pattern shapes. I always include a label as to what kind of garment the pattern produces, who it is intended for, and the date of the pattern's creation, as this can inform me that maybe after some time has passed, it can be worthwhile checking on the person's measurements to see if a new pattern might be required. I also include what thickness of rubber the pattern has been created for and the kinds of reduction used. Here we are basically including any additional information we feel we will require to help us construct our garment. This can also include such things as the order in which we might piece our shapes together and which edges overlap onto which. We often include sufficient enough information on our pattern that most often we will not have to refer to manuals on construction in order to learn more about how the garment should be put together. Finally, I make sure that all my layers are tidy, that all lines and signs and labels for each section are contained in their own folders. There's one additional bit of information we can include which I forgot at this stage, but which I'll return to shortly. But at this stage, the pattern is complete, so my next consideration is how to make them suitable for printing. The first act here is to crop the canvas down in size. I no longer need all the extra space around my drawings. I also save my work as a separate file for the garment pattern and delete the block it was based upon. The hardest amount of work we put into drawing the block is safe for future use. I can pull it up time and time again and make countless different garments from it, but I don't need it now with my final pattern. Okay, so I could use Photoshop to print my pattern or convert it into a PDF file for printing elsewhere, but very often I prefer to produce my own segmented, that is, tiled version. To make the individual sections easier and quicker to move around, I make copies of each of their folders and then, in the Layers window, I right-click on each of them and from the drop-down menus select Merge Group. All the lines, symbols and labels contained in each folder will become rasterized as a single layer. Next, using the Rectangle Shape tool, I produce a series of rectangles that in size are smaller than the paper used in my printer. As my printer takes A4 sheets that measure 21 centimeters wide by 29.7 centimeters in height, I often make the rectangles around 18 by 28 centimeters or smaller. I overlap these rectangles to give me margins between each one, where I can, after printing, align the sheets and tape them together. I then rearrange my pattern shapes within these rectangles to minimize the amount of space they occupy. And then label the sheets. Here I use letters to designate rows and numbers to designate columns. Before showing how we use this to produce our segmented sheets for printing, I'm here returning back to the pattern conversion to demonstrate the additional information we can include. This information concerns balance markers. Balance markers often use arrows or triangles to symbolize them. Balance markers can be very helpful in assisting us during construction with the alignment between sections as we join them together. So here you see me initially align the original shape edges of the two front sections together at the armhole and then pivot them along the bust and waist darts. At certain intervals along the edges I stop and draw triangles, which are placed on each section involved, either side of the butted together edges. I then continue with the pivoting to the next location. I don't really have to include balance markers at the bust line as the bust line acts as balance markers anyway, but I am including them here just for demonstration purposes. How many balance markers we include is up to us. The idea during construction is to include these balance markers on our rubber sheeting thus helping us to maintain alignment between the sections during their piecing together. So anyway, getting back to the printing. I take sectional screenshots of each rectangular area. I next open up my word processor. I have a Mac, so I'm using Pages. You might use Word. Selecting a new file in which the pages are set to the A4 size, I drag and drop the screenshots. Due to resolution issues, the screenshots are often smaller than what they should be. So I next select them all and change their size. The screenshots were 18 by 28 centimeters, so by changing the width to 18 centimeters, this rescales them. This often reveals the accuracy of our screenshots because, as can be seen, my height measurement has come out larger at 28.01 centimeters. But this 1/10 of 1 millimeter for such a small pattern does not worry me. I often give the screenshot images a line border and drop shadow effect just to distinguish their border a little better. I next need to centralize the screenshots. Here I am using the alignment menus to achieve this for each screenshot, but I could also move them all simultaneously by entering the amounts in the position boxes, which I know to be 1.5 centimeters on the x-axis and 0.84 centimeters on the y-axis. And that is it. I can now print the pattern as it is, or convert it to a PDF and print that. I thank you for watching these videos, and hopefully they may have been useful to some of you.